Hi, this is Team 8. In this video, we are going to present our proposal, which is prediction of disruptions and their cause in Montreal metro network using machine learning techniques. The metro system in Montreal has been provided by the STM company for over 50 years and chalked up over 10 billion passenger rides since it has been opened. This agency operates the most heavily used urban mass transit system in Canada. During rush hours, 80 metro trains are in simultaneous service with a capacity of 1,000 passengers per train. Due to this high operation and performance level, it is critical to improving the metro system's resilience by predicting the incidents and disruptions before they occur. Public transport disruptions can result in major impacts for passengers and operators. For public transport users, these disruptions can increase passengers' nominal travel time, in-vehicle time, and transfer time. For public transport service providers, it can result in rescheduling costs, revenue losses, reimbursement costs, and penalties. Incidents and breakouts can force passengers to travel via routes that would be illogical or non-optimal during undisrupted operations. Eventually, in the long term, disruptions may lead to a loss of income if ridership levels decrease due to vulnerability and unreliability of the public transport system and passenger dissatisfaction.
In the first objective, we aim to find the correlation between the delay time and the other characteristics of the incidents, using association analysis, specifically the FP growth algorithm. Our goal is to make the rules with the consequence of high delay time to realize which attributes correlate with the downtime. For this purpose, we have to discretize the downtime into 3 buckets, and also we need to identify the best minimum support and minimum confidence by try and error to make logical rules. For the second objective, we are going to determine what situation resulted in the train or station's evacuation. For this purpose, the same approach can be used to find the patterns with the conclusion of evacuation to understand what situations followed by an evacuation most frequently. The third objective of our study is to predict the main cause of the incident based on the other attributes. Since we have the primary causes nominal values, we are going to use a classification methodology in this case. To achieve the best result, we decided to use decision tree, k-nearest neighbors, and naive-Bayes algorithm, and then compare them based on their accuracy and choose the best one. This objective is of high value because it can improve the metro network's resilience, and it can also reduce the time, human resources, and costs that are usually spent on the inspections. As our last objective, we are trying to predict the downtime after an incident happens. This is also a part of supervised predictive analysis, but this time, as the value of our labeled attributes are numerical, we're going to use the regression algorithm.
Our dataset is published by Montreal Transit Company, known as STM, and uploaded on the Open Data portal of the City of Montreal. In this dataset, we have the cause and symptoms of each incident, the exact location and time that the incident happened, and some Boolean attributes that show if the evacuation was needed, if the emergency brake is used, if the metro emergency team is involved, and also the wagon type. To achieve our goals, we had to make some changes to our dataset. As an example, having the start and end time of each incident, we calculated the delay time and added as a separate attribute to the database. We define disruption as any incident with a delay time of 3 minutes or more. Incidents with a delay of smaller than 3 minutes are considered regular variability in a step. So our future steps would be following the 6 steps of STM for training model and achieving our objectives, implementing the algorithms, establish rules from affinity analysis, testing the verification and validation of the model, deploying the model, interpretation of the results, and making suggestions.